Hello everyone, my name is Eduard Lebedyuk, and my talk is continuous delivery of containers, deployment with InterSystems Cloud Manager. Okay, let's first have a plan for our talk. First we're going to talk about containers a little, and how can they be used on different stages of software development life cycle. Because it's different, really, different stages. You can, when you're just starting with containers, you can just not make a complete jump, but only use containers on some subset of your workflow and see if they do work for you. Next, we're going to talk about continuous delivery and GitLab and deployment with InterSystems Cloud Manager. And finally, I'll show you a short demo. Okay. Also, there are other cloud and continuous delivery sessions which are available at learningintersystems.com. Be sure to check them out. So, why do we use containers? Because they offer several advantages. And the main and one of the most important advantages is portability. Once you build your container, your image, you can think about it as an executable. And it would work anywhere. I mean, if you built it and if you tested it and where you built it, it works reasonably well, like how you might expect it to work, it would work anywhere where Docker runs. These days it's Linux, the first main operating system for Docker, but also it's Windows and Mac OS. It helps to think of your image of your built container as an executable file, as your exe file for us Windows users. So you can easily port it move from one system to another. Because all dependencies are satisfied at build time, you don't need to think about it later. Efficiency. These days, we are rarely running bare metal installations. It's usually virtual machines. But when we are talking about virtual machines and virtualizations, there is a lot of overhead. We are running operating systems. We are running system libraries. We are running services. No one cares about that usually. You only want your application to run, only your application to consume resources, and containers offer you exactly that. It's an isolation for your application, and only your processes, your application processes are run, and nothing else. Isolation. Containers are isolated from everything by default. Any interaction with containers, you need to explicitly specify that. Interaction between two different containers, containers and hosts, containers and outside world. You define it before you start. And nothing else can run. Can interact with containers. All that brings us to a lightweight. Containers are light. Containers start from several megabytes, where virtual machine starts from gigabyte probably. Other advantage is, for example, let's say you want to have two virtual machines, one with a text file which has like one line of text, and second one with text file code, for example, with 2 lines of text. And you still need two completely different virtual machines, like 5 gigabytes and 5 gigabytes. Containers are made on layers. You start from something, for example, from base Ubuntu container, and you add something. You add your own layer on top of that. So, for example, storing 100 containers, which are similar, is not going to take 100 times amount of space. It just store the difference. And finally, immutability. It's a more interesting case. Again, let's talk about our executable analogy, metaphor. It doesn't really make sense if you try to make a change in exe file by opening an hex editor and like typing some bytes in. Same with containers. Once you build your container and the code of your application is inside, it doesn't make sense, it shouldn't make sense to change it. Your data is stored on a host system, And of course, it's mutable. You add new records, you change your existing records, you query, and so on. But your code, container is one version of your code. It doesn't change. If you're writing a new code, which you obviously do, you're creating a new container with a new version of code and just swap them. I'll later elaborate why it's an advantage for us. Also, containers offer new possibilities, such as orchestration and scaling. That means that you can scale your application to perform the workload it needs to perform right now. And when you don't need these new resources, for example, during the night, you see a downtime or you see a low request volume, you can just unprovision some containers and free the resources for something else, or just if you're using cloud providers, to not pay at all for them when you don't need them. Okay, so this was some very brief, very general overview of containers. And now let's move to software development lifecycle and how containers are used there at different stages and what advantages they give us. So, very abstract software development lifecycle. So first is implementation part. We start with development, and it's easy because all you need to do once you have Docker running is perform two commands: Docker pull and Docker run, and that's it. And you have your application running. It's awesome. You don't. You know, if you have some big application and there is like this long instruction of steps you need to get a new base running, it takes time. Nothing of that with Docker. You just Docker pull your image to your local host and you run it. That's all. All dependencies are already resolved and they're inside the container. Libraries, frameworks, operating system versions. You just don't think about it at all. You just have your container and it runs. Debugging. Because containers are immutable, which is not the case with traditional applications. If you have your production server and it runs for years and you upgrade it in place, it becomes very unique. There are like library versions, there are some registry changes and so on. You just do stuff. It's live. Of course, you need to change something sometimes. But if some bug, you find bug, yes, what to do? Because you can't easily reproduce the environment you have in production locally. There's no problem of that between containers. You just pull your production container locally and it would be absolutely the same environment because containers are immutable. So it's easy to recreate an environment you need and easy to start debugging. Testing, QA. For testing, you can share containers, not bugs, and your current infrastructure is always documented because container is a result of a source code of sorts. You specify where you start, you specify what you do with your container, like install some new software and so on, and the result is your binary. So this source code is in your source control system. It's automatically documented. You have it, you have a history of changes, and it is the problems with testing, with quality assurance, and so on. Fewer variables, I said about it, less libraries, version, frameworks, everything is standardized. You can run tests in parallel. And delivery. First of all, you compile build once. Usually you have a separate build server, which only runs Docker, and you build containers there. And afterwards, if you need, after it's built, it's published to a Docker registry, which is simply a registry of your images. And if someone somewhere needs an image, he just pulls it, and that's it. He doesn't need to recompile to do stuff at all. It brings greater maintainability and container isolation, because containers are isolated by default unless explicitly specified. It increases security. Okay, that's about software development lifecycle and advantages containers can bring us. Now let's talk about continuous delivery more in detail. I would use a GitLab as an example, but I'd like to say that there are many different alternatives like Jenkins, Atlassian, Jira, Bamboo Stack, Microsoft Team Foundation Server, and many, many others. They're similar in a lot of points. I would use a GitLab to present and show my demos, but of course you can use any tool you want. I'm not particularly advertising one over another. Okay, so what's GitLab? It's a Git repository management. It has issues, it has wiki, continuous delivery pipeline, all you need to develop. Okay, so you start with issues. If you're working, for example, on GitHub or on GitLab or on Jira, it starts with issue. Issue is one piece of work. It could be a bug, feature, documentation, new test, whatever. It has discussion, related commits, and related branch, hopefully. For a more high-level view of issues, we have planning, which are Kanban boards, which are sprints, milestones, versions, and so on. So you can group your issues into clusters, so you can have a more high-level overview of it. For each issue, you can usually prescribe a due date, a developer, and developer can clarify how much time did he spend on it. Yes? So finally, we are moving after we have our commit into continuous integration and continuous delivery. It's a software engineering approach which automates building, testing, and delivering your application. In GitLab, it's a configuration via YAML. It's a series of consecutive stages, and each stage has scripts, which is one action, and each scripts are executed in parallel. So your continuous delivery configuration has all the actions you may ever need. But if something triggers, for example, a new commit to a master branch triggers your continuous delivery configuration, only a subset of actions, of scripts, should be executed. For example, if we have a new commit to a master branch, we can only need to do stuff related to a test server. And if we have a new commit to a production branch, we only need to execute a subset of scripts which are related to our production environment. So pipeline is exactly one execution of this subset which we actually need to execute. It contains logs, what was executed, and the results. Finally, we have environments, which simply are pointers to some of our, servers. It could be actually a server, it could be a container, it could be a virtual machine, whatever, it doesn't matter at all. It has a name, a link, how can we access it, execution history, and we can roll back to any point in its history. Could be useful. So finally, I want to talk a little about the difference between continuous integration, continuous delivery, and continuous deployment. Here's a handy diagram which explains the relationship between them. So we start with continuous integration, which is our ability to build and test. Continuous delivery is our technical ability to deploy automatically. But at continuous delivery stage, it's still a business decision. Moving between version 1 and to version 2, we need to sit down and decide, yes, this is about as bug-free as we can reasonably make it, and we need to make this move. When we press a button, and the move actually happens automatically, but we decided as humans that we do need to make this move. Continuous deployment is a practice where we don't decide that. As soon as we have a new version, we move to it. So you can start with continuous integration and move to continuous delivery if you're very sure that your deployment and bugs doesn't really make it to deployment stage, and you can even move to continuous deployment if you're sure. So how does the workflow all looks together? First, we start with development. Developers start developing in his favorite IDE. It could be Atelier, it could be Studio, it could be whatever, really. And commits his code into Git, probably, or honestly any other version control system. Next, our driver our driver for continuous delivery starts working. In our case, it's GitLab. GitLab takes source control in a repository and our Docker file, which is a specification of our image, and combines them together in a build part. So we built our binary, which is an image. Next, after we built it, we publish it. It could be a private publishing on something called Docker registry. You can run your own Docker registry, no problems. You can authorize, or it could be even public, or so whatever you want. Finally, after we have a Docker registry, our new image there, we are running it. We can run it everywhere. We can run it into Amazon, into Google, into Azure. We can run it locally. We can run it or bare metal, whatever. So InterSystems Cloud Manager. Let's talk how can it help us with that last part, run mainly. It's an enterprise infrastructure solution abstraction, and in there you declaratively in a JSON file you define what do you need. You define how much servers you need, what namespaces, do you want mirroring, do you want sharding, what roles, how much query servers, how much data servers, and so on. And then you just say provision this for me and run InterSystems Iris for me there once it's provisioned. That's it. It also provides a range of supplementary services such as upgrading what's once provisioned, unprovisioning, executing SQL on servers, executing commands on servers, and so on. And it's all declarative. You provide a JSON template with your definition of what you need, and it just gets done. Okay. I'd like to talk a little more about upgrades because it's one of the most important part, and InterSystems Cloud Manager enables upgrade. You can change the container version from one to another. Actually, with InterSystems Cloud Manager, you can run any container. It's absolutely not locked to InterSystems Iris container. It has some additional features for InterSystems Iris container, so you can use it better, but you can run any other container too. Absolutely not locked. So, upgrades, the hardest part. What do you need to remember? Schema migrations, yes, especially if you're deleting something. Configuration changes, running tests, and in general, if we are, talking abstractly, it's like pre- and post-installation compilation hooks, which you need to execute arbitrary code at that parts. So you need to remember about that during your upgrades before you start your upgrades, or you're going to do it manually. So let's move to a demo. It's very big. It's actually 4 different servers, which I'll now talk about. First of all, it's our GitLab server. Next, it's our Docker build server, which you build our image. And it's our test server and the live server, and they're all online. Hopefully they all work together. Okay, let's talk about application. Application is very simple. It's an HTML client and InterSystems Iris REST API, which return information about available classes, about for each class available objects, and about each object we can see its properties. So it's like a simple navigator first on list of classes, list of objects, and object details. And HTML Angular visualization of that. So what's our plan? First, we commit some code which would trigger our continuous delivery pipeline. We build new image and push it to Docker registry. Next, ICM automatically upgrades test server to this new image, latest version, run tests, and if tests are successful, we'll have a button which if we press, and we are moving live server to a new version. And during all that, let's check our new deployment. We'll see a new application version on test on live servers, but the application data is persisted between containers because actual application data is stored on host using durable person sys feature, which allows us to store settings, configuration, and other databases, not person sys only, on host. Okay, let's see our continuous delivery configuration. Just a second, okay. You see it. So we have 5 stages. First we build our image, next we publish it to Docker registry, run it on a test server, execute unit tests, and finally deploy to a production server. For build image, we're running Docker build with some arguments and build our new image. It essentially just loads the code inside the container. Next we publish it. We're logging into my account with secure storing of a password. It's replaced with actual password. Don't try it as a password, it won't work. And we're pushing our new image, just built, into our registry. Next, we're using ICM. First, we're logging inside ICM container and calling ICM upgrade to upgrade our application to a new image. Next, we're running tests. Again, we're using InterSystems Cloud Manager. ICM sessions just gives us a session, and we are executing unit test command. It's like there. Yeah, unit test manager run test. And finally, we're deploying our image, which is the same ICM upgrade to a live server. We can see it. We are executing in a live environment. And the most important change is we're executing it manually. As you see, there is a when manual, so we need to press a button. And it's not done automatically. Okay, let's see our test server and live server. Here's a test server. As you can see, it's a version 2.1. It has 3 classes. Let's say a person class. There's one record called dead. And on our live server, we have 2 records, Alice and Bob. Okay, and it's also in version 2.1. We're opening Atelier. And here's our change the version, compiled on our local server, and we're committing this change. You can see I'm using TurtleGit. I'm a fan of it, but you can use Yagit inside Atelier or some other client, even console tools, for example. It's also a way to do this. And we're pushing our new commit to a repository. Okay. We have our 2 environments list, and if we now go to pipelines, okay, we are seeing a new pipeline which is related to our new commit version 2.2. It's running currently on the first stage. Let's go see it. It's building our image, and we're seeing logs in real time. All it does really is load the classes, creating a REST application or stuff like that. Okay, so when we're publishing our image, okay, and running it. What happens when we're running new image? First, we're downloading a new version, new image from our registry. When we're stopping our container and starting a new one. So all the downtime you experience is shutting down and starting up of a container. It happens in a few seconds for Iris, plus the time you need for your application to start up and shut down. As you see, first we download the image, and okay, let's see it. Here's our test server. We even have the same session, so we don't need to re-log in, and we're now on version 2.2. but the data stays the same because the data is always stored on a host. It's never inside a container. So I can continue modifying my data, adding some new one, and upgrading the versions of our application. It's all, and the data is safe. Okay, let's return to our pipeline. Our pipeline will run tests successfully. And yes, deployment, we're waiting for our action, because if we see our live server, it's still in version 2.1. Yes, 2.1. And after we are reasonably sure that no new bugs were introduced, we are pressing a button to deploy, to execute this action, and it automatically does the same. So downloads the new version of image on a live server, stops the old image, old container, and starts a new container. Let's wait a little. As you see, there is a complete, it's all cross-linked. We can go to pipeline, we can go to a commit which made the change, to related discussion, we can see duration and stuff. Takes a little while, but the application is actually running during that, so it's not actually a downtime. Okay, let's see our environments. You can go here. There is a list of environments. We currently have only 2 environments. And for each environment, we can see complete version history of deployment history. We can see that I've done this presentation several times. There's okay. Oh, yeah. Here we go. Okay, and let's go see our live server. We are refreshing it, and we see that our version is now 2.2, and the data stays the same. Okay, so let's continue with our presentation. It was for a demo. Let's rehash a little what we've done. We commented new code. It triggered a continuous delivery pipeline. We built a new image, pushed it to Docker registry, upgraded the test server, run tests. Tests were successful, and we decided to move production server to a new version. ICM upgraded live server, and during all that, we checked our 2 deployments, test and live, but data stays the same, but application code changes, because application code we store inside our container, and data is stored outside on a host. Conclusions. It's easy to start running containers. There are many tools to choose from. If you don't want to work with command line, there are a lot of tools which allow you to choose a container image from list and specify all arguments in a graphical way. For example, there's Portainer, there are a lot of tools. You can start running containers, using containers only some subset of your workflow, only for development, for debugging, for some subset of changes. Continuous delivery using containers allows you to create a flexible workflow. Continuous delivery is a very big branch of practices, and you can tailor your workflow, your continuous delivery pipeline to what you need. You can run 1 server, you can run 10 servers. For each new server, for each branch, for example, you can create a new URL automatically and point your users to it, or your testers, and so on. InterSystems Cloud Manager does provisioning and deployment for you. You can easily provision clusters with InterSystems Iris, and you can easily upgrade them with InterSystems Cloud Manager. Now some links. You have this presentation PDF file in your mobile application. There is also a handy link which also points to the same presentation. There are developer community where you can read some articles about containers, container images, my 10-part series of articles on continuous delivery of your InterSystems solution using GitLab. There's also InterSystems Cloud Manager documentation and a lot of resources on learningintersystems.com. Okay, thank you. And do you have any questions? Please ask them. Yes? You can use a microphone, you're right near it. So
why use InterSystems Cloud Manager over Ansible and Vagrant and things like that?
Why use InterSystems Cloud Manager instead of
using Ansible, for example?
You can actually use Ansible or just any other tool to automate, but InterSystems Cloud Manager can greatly simplify configuration because it does configuration for you. You just specify you want mirroring and it's done. You need to, like log into server or automate creating a mirror configuration. You can automate it, yes, but it could be just easier. But if we're talking about automatic of your delivery, building, testing workflow, you can do it with traditional configurations. You can do it with just containers, and you can do it with InterSystems Cloud Manager. So check it out and decide what's best for you. Yes?
How are license keys handled?
The question is how are license keys handled? And you need license inside your container. Yes, and when you run it, you have a special argument, key, which is a value, which is a path to a key. You specify it, and your license is loaded inside the container and consumed. Your InterSystems Iris container can consume all resources which are available on host. So, for example, if you're running like 48 cores and terabyte of RAM, you can run it with container. You have one InterSystems Iris container on this host, and it consume, if you specify it in like global buffer and stuff, it would consume all the resources available. Or using, again, Docker, you can specify, I want, for example, my InterSystems Iris container consume 95% of RAM tops. And you, on the remaining 5%, you're running some monitoring, so you can, not go into 100, for example. Okay. Any other questions? We actually have a few more minutes, so if you, yes?
Hi. I'd like to do a sort of informal poll. I'm just curious, how many people are using a pipeline like this for your development process already? Like, anybody? 1, 2? Does this look interesting to people? Okay. Thank you.
Using automation saves time and it saves you errors because if you're deploying something once, it's really not that big of a problem. But if you're deploying 10 times, 100 times, and it's a repetitive task, you start just, I remember how it all works, and then mistakes crop up. Continuous delivery saves you time, and it saves you effort, saves you money. Okay? Any other questions? So, thank you for your attention.